One of the most important sources of energy to recognize today is geothermal power. According to a 2006 MIT report, about 2,000 zettajoules of power is currently tappable worldwide. The total energy consumption of all the countries on the planet is only half of a zettajoule a year. This means about 4,000 years of planetary power could be harnessed immediately in this medium alone. As far as wind energy, a 2005 Stanford University study published in the Journal of Geophysical Research found that if only 20% of the wind potential on the planet was harnessed, it would cover all the world's energy needs. As far as solar energy, the sun's radiation striking the Earth's surface each year is more than 10,000 times the world's annual energy usage. From simple photovoltaic panels that can capture energy into storage batteries for private use, to full-scale solar power plants, new technology is constantly emerging, which is vastly improving this potential. Lesser known is tidal power, which is derived from tidal shifts in the ocean. Installing turbines which capture this movement generates energy. In the United Kingdom, 42 sites are currently noted as available, forecasting that 34% of all of the UK's energy could come from tidal power alone. However, more effectively, wave power, which extracts energy from the surface motions of the ocean, is estimated to have a global potential of up to 80,000 terawatt-hours a year. This means that 50% of the entire planet's energy usage could be produced from this single medium. In view of all of these options, energy is nothing but abundant on this planet. The only reason people today think it might be scarce is because of the monetary system's strategic propensity to create the scarcity. The next question is, what about industrial raw materials? Can the Earth's supply of raw physical materials such as wood, iron ore, aluminum, and such support the needs of the world's population? Global mineral reserves are currently measured by commercial output production. Sadly, this does not give a clear picture of what is actually available. While some elements and minerals are vast in abundance, such as silicon, aluminum, and iron, others are seemingly growing scarce, such as copper, lead, zinc, gold, and silver. As far as we know, there has never been a complete geological survey of the Earth's minerals and elements, only regional ones. This must be done in the future for us to have an understanding of the dynamic equilibrium inherent. Regardless, there are basically three components to understanding the carrying capacity of the Earth. Knowing exactly what the Earth has as far as component elements and materials, where technology is in regard to creating synthetic substitutions for certain elements and materials, and how society organizes and manages its use of these resources. The first thing we need to do is have a full survey of all of the planetary resources. This will give us key information on how to proceed with our operations. For example, if we have an acre of land that we want to grow food with, the first thing would be to test the soil to understand what type of propensities it has. This information would have a direct relationship to what can be grown. This would illuminate the carrying capacity of the land, so to speak. In regard to scarce materials, finding substitutions is always an important pursuit. Many scarce industrial materials today now have synthetic counterparts, and the focus of scientific problem solving in this regard is very important. With this understood, we should realize that the scarcity of most raw materials are only as relevant as the amount of work being invested into finding a substitute or workaround. More important than substitutes and workarounds is the very nature of our usage of the planetary resources. Production output in the world today is staggering compared to the past. With the use of technology, we are able to produce more with far less people faster than any other time in history. However, due to the profit system, there are tons of manufacturers producing the same things as they compete for market share. As noted before, the world's people function within a monetary system that rewards scarcity, planned obsolescence, waste, pollution, and multiplicity. The true cause of scarcity on the planet has less to do with the available resources and more to do with our wasteful and exploitive modes of conduct. Virtually no regard is given to conservation or strategic use until it is too late. In a saner society, the raw materials of the planet would be assessed, industry would be organized as a whole to produce in relationship to what was available, and each item produced would be designed to last as long as possible, causing reduced industrial output and hence resource preservation. Now, when it comes to food production and water preservation, the same monetary system problems of pollution, cost-cutting processes, and scarcity come into play. Water covers 70% of the Earth's surface. Technological advancements such as desalination processes can make fresh drinking water both from seawater and even brackish sources using reverse osmosis. This is yet another example of how technology is just as much a part of resource management as resources themselves. The idea that usable water is scarce is true only in relationship to the limited methods we are currently using, coupled, of course, with the gross industrial pollution that goes on daily. Food production is also expanding within the technological spectrum, creating vast new methods of cultivation. For instance, the Earth's surface is indeed being abused, with its precious topsoil being corrupted by different agricultural methods. According to some reports, we are losing topsoil at a rate of 1% a year, while the National Academy of Sciences has determined that the cropland in the U.S. is being eroded at least 10 times faster than the time it takes for lost soil to be replaced. Fortunately, scientists have devised a new form of soilless agriculture called hydroponics. This powerful new medium leaves a sea of options for the human population, for not only in compensating for the damage we have caused, but also by expanding the possibility of when and where food can be grown. With hydroponic agriculture, we could theoretically grow food in the middle of the desert with proper irrigation or by tapping down to the water table. The bottom line is that food, air, and water are only as scarce as we decide they are. If we choose to become intelligent and strategic with our production and preservation methods, while taking full advantage of scientific inventions that maximize our production capabilities, reducing waste and inefficiency, we can provide for the planet's people many times over. The starving children of the world are not so because of a lack of available food. It is their lack of purchasing power, not scarcity, which causes the needless deaths of millions a year. The means for social evolution. In this section, we are going to consider more specifically what it is we actually want and need in this world. What do we value in life? While there are many broad opinions in this regard, most people would prefer that they have clean air and water, nutritious food, material abundance, fast, clean, and efficient transportation, irrelevant education, public health care, the end of war, an environment that enables us to constantly improve our abilities, human extensionality, reduced stress, and reduced crime. We would consider these necessities and aspirations our goals. With our basic goals denoted, we must then think about the methods to be used in order to accomplish those goals. Unequivocally, the scientific method is the most powerful tool we know. Observation, logic, and testing have long since trumped superstition, intuition, and metaphysics. In the words of Carl Pearson, there is no shortcut to truth, no way to gain knowledge of the universe except through the gateway of the scientific method. The intelligent use of the methods of science is what has brought us nearly everything that helps us in our daily lives. The application of science to social organization as a whole is the next step in our evolution. Furthermore, to fully utilize the scientific method, we will need physical tools that can make our material needs possible. These material tools come in the form of technology. From a simple hammer to a high-tech, fully automated production plant, technological invention continues to ease production methods while also consistently making what was once deemed impossible, possible. The history of technology has shown tremendous accelerating development. Coupled with the scientific method of thought, the technological tools currently at our disposal have the ability to dramatically change humanity in ways most would find too fantastic to be true. For instance, if you showed a cell phone to a man from the 12th century, he would probably be shocked beyond comprehension at the magical instrument. Science and technology has continued to defy prior assumptions of possibility and will continue to do so. It can safely be assumed that whatever the future holds, from a technological standpoint, it will likely seem impossible and ridiculous from the standpoint of today's understandings and methods. Now, coming back to our larger point, the three attributes of personal and social evolution are thus our goals, the method of thought, and the tools to get it done. We define our goals based on what we value. We utilize the scientific method to solve problems and create hypotheses, and we harness technology to make the goal a reality. Part 3, a resource-based economy. In this section, we are going to address the Venus Project and its advocation of a new social system called a resource-based economy. We will describe its basis in regard to industry and labor, specifically discussing the role of technology and automation, while isolating the 5 most important steps to achieving the most efficient and effective production methods possible. Then we will address the role of so-called government in this new system, explaining the arcane nature of the institution as it exists today, and how, through the use of advanced decision-making methods, we will be able to remove the dangerous subjectivity and self-interest currently at work, and rather we will arrive at decisions based on the scientific method with the use of computer technology.